This is the Unit 2, Section 1 Ed puzzle on atomic structure. So what are the three parts of any atom? Well, in an atom, we can see there are three different pieces. There are these small negative spheres around the outside of the atom, these blank orange spheres in the center, and these yellow positive spheres also in the center. Now, these colors don't actually exist. They're just a way for us to visually separate the different pieces. If we first look at the positive yellow spheres, those are our protons, and they're in the center of our atom, which is also called the nucleus. If we instead look at those orange spheres with no positive or negative, they're neutral, these are our neutrons, and they're also in the center of our atom or in the nucleus. And finally, the small negative spheres around the outside, those are our electrons. Those are around the outside of our atom. And they do exist in certain spaces, but for now, we'll just say they orbit the nucleus, sort of like planets around a sun. So, what are the properties of each part? Well, if we look at our protons, we can see that they have a positive charge. That positive in the center kind of gives it away. And we can remember that by thinking protons are positive. It has the same beginning sound in the word. Now, these do have a mass of 1 each. In fact, their charge we say is positive 1, and their mass is worth just 1. Our neutrons, they are neutral. Also have the same beginning of that word. Neutrons are neutral, so they have 0 charge. But they also do have mass, just like protons. Every neutron has a mass of 1. Our electrons, we can kind of give it away based on the image here, they have a charge of negative or a negative 1 charge for every electron. There's no kind of clue here. We just have to remember that electrons are negative. Also, our electrons are so small that we basically say they have no mass. They don't really weigh a lot when compared to the other particles. So we say they don't affect mass. When it comes to an entire atom, we can also talk about mass and charge. The atomic mass is our total number of protons and neutrons. In other words, our mass equals number of protons plus number of neutrons. And the charge would be the difference between our protons and electrons. Now, I have one system of doing this where I say the sign is whichever particle there is more of. If we have more protons, it's positive, and if we have more electrons, it's negative. So if we have, say, 7 protons and 10 electrons, I would say we have a negative charge overall because there's more electrons. And the amount of charge is how much of a difference there is. So again, if we have 7 protons and 10 electrons, I would say this is a negative 3 charge because there's a difference of 3. A quick equation for that is that charge equals number of protons minus number of electrons. Alrighty, let's have you try one. An atom has the following amounts of each particle: 4 protons, 5 neutrons, and 3 electrons. What is this atom's mass? Go ahead and answer. This atom would have a mass of 9 because there are 4 protons plus 5 neutrons. We can ignore the electrons when it comes to mass. 4 plus 5 is 9. Now, what is this atom's charge? This atom has a charge of positive 1 because there is 1 more proton than electron. So there's a positive, because it's protons, 1 charge. You could also do 4 minus 3 to get that positive 1. Let's try one more. A different atom has the following amounts of each particle: 17 protons, 21 neutrons, 19 electrons. What is this atom's mass? This atom would have a mass of 38 because 17 protons plus 21 neutrons gives us 38. Next, what is this atom's charge? This atom would have a charge of negative 2 because there are 2 more electrons than protons. You could also do 17 minus 19. All right, let's see what you remember from the first part of this presentation. Where are the protons located in an atom? All right, what about the neutrons? Where are the neutrons located? And finally, Where are the electrons located in an atom? All right, we have one more topic in this presentation, nuclear notation. We can use something called nuclear notation to show all of the properties of an atom all at one time. And in general, we would say that the atomic symbol goes in the center, the number of protons goes in the bottom left, the mass goes in the top left, and the charge goes in the top right. So for instance, if I have an atom with 6 protons, 7 neutrons, and 5 electrons, I would say my symbol is C for carbon. We'd get that from the periodic table. My number of protons goes in the bottom left, 6. My mass, 7 plus 6 is 13. That mass goes in the top right. And my charge, positive 1, because there's one more proton than electrons, goes in the top right. Let's have you try one. An atom has the following amounts of each particle: 9 protons, 10 neutrons, and 10 electrons. First, what symbol will go in the center of this nuclear notation? What's going to go in the center here? That's going to be F for fluorine, because fluorine is our 9th element. What symbol is going to go in the bottom left here? That's going to be 9, because we have 9 protons. What about the top left? What number will go in the top left here? That'll be 19, because this is the mass. 9 protons plus 10 neutrons gives us 19. And finally, what will go in the top right? This will be negative 1, because there is one more electron than protons, so it's negative 1. All right, let's take one of these examples in reverse. How many of each particle does this atom have? This is scandium. You can find it sort of near the top left of your periodic table. How many protons does this atom have? This atom has 21 protons, and we can see that because this number in the bottom left is our number of protons. How many neutrons does this atom have? This atom would have 24 neutrons because 24 plus 21 gives us 45, the total mass in the top left. And finally, how many electrons does this atom have? This atom has 18 electrons because it must have 3 more protons than electrons, because we know its charge is positive 3. You could also do 21 minus 18 to check, see if you get plus 3. And that is it for the Unit 2 Section 1 quiz on atomic structure.